We're trying to find the volume of the region that is inside the cylinder with a radius of 5 and beneath the sphere with a radius of 10 and above the XY plane. I've drawn that to scale using maple. And so here we have the blue cylinder and the gold sphere. Now I've got these chopped off at the XY plane. So we can look inside of the cylinder and see the dome, and likewise from the bottom. Now we're told in the hint to use cylindrical coordinates. So I'm going to use cylindrical coordinates. If I look straight down the top at the XY plane in cylindrical coordinates, the R will be from the center to the cylinder. The cylinder has a radius of 5. The theta, since we go all the way around, would be 0 to 2 pi. Now the value of z in cylindrical coordinates is the same as the value of z in rectangular coordinates. So again, we will begin our triple integral with a dz, since that is going to contain the other variables. If we take the sphere and solve for z, remember, x squared plus y squared is the same as r squared. Since we're looking at the part above the xy plane, we'll use the positive square root. So our integral then is going to contain the r as part of the integrand for cylindrical coordinates, and then we will begin with the dz, where the z goes from 0, the xy plane, up to the sphere, which would be z equals the square root of 100 minus r squared. Now it doesn't matter what order we do the next two in, because they're both constants. So we'll do dr 0 to 5 and d theta 0 to 2 pi. Now this would be simple to do on the TI-89, but it's not too bad to do by hand. To do by hand, we'll need to begin with the innermost integral. So when we integrate first with respect to z, we will have an r times z. Now that's going to be from a z equals 0 to a z equals square root of 100 minus r squared. So plugging in the square root of 100 minus r squared in for z, we get r and the square root of 100 minus r squared. Now plugging in the 0 for z, we get just 0. So in the next step, we need to integrate that with respect to r from 0 to 5. We will do this with a normal substitution from back in Calculus 1. We'll let u be 100 minus r squared, which means du would be a negative 2r dr. So we need a negative 2 and a negative 1/2 in order to have our substitution. We'll go ahead and use this to convert our limits. The r equals 0 would convert to u equals 100 minus 0. the r equals 5 would convert to u equals 100 minus 25. So then our integral becomes from 100 to 75 of the square root of u, or u to the 1/2 power. And this comes out to be a u to the 3/2 divided by 3/2, or 2/3 u to the 3/2. So plugging in the 75, then the 100, and subtracting, we come up with a negative 1/3, and 375 square root of 3 minus 1,000. Now, I don't really want to write this down, and the final answer is going to be rounded off anyway, so I'll go ahead and type this into my calculator and round it off, but further than the final answer. So then our final integral would be the integral with respect to theta of that number. So we want the integral from 0 to 2 pi of a 116.82698. Now that's just going to be a 116.82698 theta, which we will plug in the 0 and the 2 pi. And again, we'll just round them off.